Hi guys, today we're going to talk about linear functions, and we're going to relate it back to our last unit on proportional relationships and ask the question, how are linear functions used to model proportional relationships? And it's pretty simple, and I know we briefly touched on it in class, and I think you guys are going to do just fine with this. But our I can statements today, or what we'll learn today, is I can determine whether a relation is a function, and I can write a function using function notation. Okay? So, let's go over some vocabulary. A function, in a very simplistic way, is a rule that we use to describe a relationship. Okay? An independent variable, we've already talked about. It is the variable in our situation that acts independent of anything else that's going on. For example, time, we often use as an independent variable because it's going to keep going no matter what happens with our dependent variable. It keeps going on. It is the variable that acts on its own. And the dependent variable acts in reaction to what the independent variable is doing. So for example, we talked about driving in a car. So if I was going 50 miles an hour, hours would be my independent variable, and the distance I traveled depends on how far I've gone, or how long I've gone, because I'm going 55 miles an hour. So that part doesn't change. That's our rate in the situation. But we'll get to that later on in this unit. We're going to talk about the vertical line test, and it's a test that we can use to determine if a graph is in fact representing a function or not. A function rule is really just, it's going to be very similar to writing an algebraic expression. It's the rule we use to describe a pattern. It's going to be a little different because it's going to have an equal sign, and the notation, the function notation, the way we write our rule, is going to be a little different from what we've already talked about. But basically, I think you're going to look back at this information and say, oh, we've pretty much already learned this. So let's go ahead and look at an example. I need to be able to determine whether each relation is a function and explain. Now in class, we talked about a couple of different ways that we can determine if we've got a function in some relationship. So looking at letter A, we said that in order for it to be a function, it's got to have only one y variable for every x variable. And we determined that after looking at the vertical line test, which we'll review in a second here. But if I'm looking here, I've got 54 as an x variable, and I've got 54 again here. But if I look at the y variable, they're different. This means that when I graph them, I'm going to have two points in the same vertical line. If I have 2 points in the same vertical line, I'm not going to have a function. Same applies for 56. If I look at my two ordered pairs that have 56 as an x variable, I notice that their y's are different. So therefore, those 2 points are going to fall on the same vertical line. So A is not a function. Oops. Okay. And our reason is because 54 and 56 in the domain, and domain is another word for the x values. Okay, so the domain represents our x values, and they're paired with two different range values, and range, so domain is our x, range is going to represent our y value, be represented by our y values. Okay, so since 54 and 56 have two different range values, this cannot be a function. Looking at letter B, I can look and say, okay, I've got these x values. I've got 4, 7, 6, 3, 5, 2. None of those repeat. So none of those, according to what I have in the table, if I were to only graph that for my function, none of those will fall in the same vertical line because each domain value is paired with only one range value. So now it's your turn. Whoops. Check out this example, and I will get rid of this in a second here for you. There we go. Check out this example and determine whether A is a function and explain why, and whether b is a function and explain why. Okay, let's look at a graph. If I wanted to determine whether a graph is a function, I simply have to do the vertical line test. And the vertical line test means that at any point on this line, if I were to draw a completely vertical, now vertical means it goes completely up and down, forms a right angle with the bottom of the graph, anywhere on this graph that I draw a vertical line, I'm only going to hit the graph, which is the blue line, I'm only going to hit it once. Therefore, I know that this is a function because it passes the vertical line test. Now it's your turn. Go ahead and determine if the graph of these points represent a function and explain your answer. Now let's do some problem solving with these ideas. Or let's look at what functions, how to use a function and find the value of a function. So when we write functions, we write this little f of x in front of it. And what that means is it's going to give you a value. So the function of any number for this particular pattern is going to be 4x minus 7. And to find the value of it, we're given f of 5. What that means is I'm going to take 5 and plug it in for x. So all this really tells us to do is to substitute. So I'm going to get 4 times 5 minus 7. Oh my. I apologize for my pen. So let's just go ahead and look here. First, I'm going to write the function, replace the x with the value that I've been given, and then simplify or evaluate. So when I plug 5 into this function, f of 5 is going to equal 13 because 4 times 5 is 20, minus 7 gives you 13. So the value of f of 5 is 13. Let's look at letter B. First thing I'm going to do is plug in -6 for x. And then I go ahead and simplify. So I'm going to, where I see that x, I'm going to make it -6. And 4 times -6 is -24. And -24 minus 7 is -31. So it's your turn. Go ahead in the work section of your WSQ and find the value for this function of f of 7 and then f of 4. Sorry, f of -4. So now we're going to talk about using function notation. And this is pretty simple. If Mariah spends $22.50 downloading songs to her digital music player from an online music store for 90 cents each. So let's identify the independent and dependent variables, then write a function to represent the total cost of any number of songs. So basically, you're just writing a function rule. And a function rule is just an algebraic expression that you write for the situation and make it equal f of x. Then we're going to use that function to determine the number of songs that Mariah downloaded if she spent $22.50. So let's look at the steps we would go through to solve these two problems. First, since the total cost depends on the number of songs purchased, the total cost is C, is the dependent variable because how much I pay depends on the number of songs purchased. And we're going to use the S to represent the number of songs purchased, and that would be our independent variable, because I can control how many songs I purchase, or the number of songs I purchase determines the total cost. So, just a side note, let's translate these words into a function. The total cost, so the cost of S equals the cost per song times the number of songs that are purchased. So we've got this 9/10 S, and I'm sorry for that being so small. There's new program I'm using, and I apologize for that. But so C of S equals 9/10 S. Now, many of you probably right away were thinking, oh, well, I just need to take 9 times the number of songs, or 90 cents, sorry, or 9/10 times the number of songs, and that's going to give me the 22.50. So this would be my function rule. C of the cost of S equals 9/10 S, or 90/100th S. You could have put that 0 at the end. So here's our function. C of S equals 9/10 S. So let's look at B. If I wanted to solve this, I would take C of S equals 9/10 S, which is my function, then substitute $22.50 for C of S, because that is the cost. So now here in the last one, we were given the amount to put in for S, but in this problem, we're actually given the cost. So determining what we have is going to help determine how to write our function. And when I solve that by dividing both sides by 9/10, I get 25 equals S, or Mariah downloaded 25 songs. Now it's your turn. In the work section of your WSQ, solve this problem for Mrs. Newton. Okay, let's review that first question that I gave you at the beginning of this lesson. How are linear functions used to model proportional relationships? So you might need to go back in your notes and remember what a proportional relationship is, but describe how linear functions are used to model those relationships. Do that in the summary section of your WSQ and underline or highlight it. And I have one last question for you, our final lesson question. Give an example, I guess it's not a question, request. Give an example of a relation that is a function and explain why it is a function. So think of all the problems we've solved this year, and maybe you might want to select one of those. But you can also create your own example of a relation that is a function, but be sure to explain why it is a function in the work section of your WSQ. We are done with this lesson now. You can go back and watch any portion of this lesson as many times as you need to, or the whole lesson. But don't forget to WSQ in your notes.